What if I told you that under the right conditions, your own shadow could become the centerpiece of one of the rarest and most beautiful light displays in nature? Picture this. You're hiking up a misty mountain trail, the air cool and damp against your skin. As you reach a high ridge, the sun breaks through the clouds behind you, and suddenly you notice something impossible. Around the shadow of your own head, projected onto the fog below, there's a series of glowing, rainbow-colored rings. They shimmer and pulse, almost like a halo. It feels mystical, otherworldly, as if you've stepped into a legend. But this isn't magic. It's one of nature's most precise and exquisite illusions. The glory. So what exactly is a glory? And how can something as simple as a shadow create rings of colored light? Let's start with where you're most likely to see one. Glories usually appear when you're standing with the sun directly behind you, looking into a cloud or fog bank below. Airplane passengers sometimes spot them on the tops of clouds during flight, but the effect is the same. Your shadow falls onto a screen of tiny water droplets, and around that shadow's head, a luminous bullseye of rings appears. The colors are soft but distinct, red on the outside, blue toward the center, and the whole pattern seems to hover just beyond reach for centuries. People who witnessed this phenomenon had no explanation. Sailors called it the Brocken Spectre, named after a peak in Germany where it was often seen. They interpreted it as a supernatural sign, a ghostly apparition, or a divine message. But science would later reveal that the glory isn't supernatural at all. It's the result of light waves interacting in a way so intricate. It took decades to fully understand, to grasp how a glory forms. We need to dive into the journey of a single sunbeam. When sunlight hits a cloud, it's made up of countless tiny water droplets, each one acting like a miniature lens. Now, most people know that raindrops can create rainbows by refracting and reflecting light. But glories are different. They're not made by simple refraction. Instead, they rely on a far more delicate process: backscattering and wave interference. Here's how it works. When a light wave enters a water droplet, it doesn't just pass through or bounce off cleanly. Some of the light gets trapped inside, skimming along the inner surface of the droplet before being sent back in the direction it came from. This is called backscattering, but that's only half the story. Because light travels in waves, these returning waves can either reinforce or cancel each other out, depending on the angle they exit the droplet. Think of it like dropping two pebbles into a still pond. Where the ripples overlap, they can create bigger waves or flatten out completely. Inside each water droplet, light waves do the same. Only certain colors, certain wavelengths, survive this interference at specific angles. Red light tends to emerge at a slightly wider angle than blue light, creating that signature ring pattern. Red on the outer edge, then green, then blue toward the center. But why do we see multiple rings? That's where the path of light gets even more complex. Some light waves take a longer journey inside the droplet, circling once, twice, even 3 times before exiting. Each of these paths produces its own set of rings, nested inside one another. The first and brightest ring comes from light that made one internal reflection. The fainter rings come from light that circled multiple times, losing a bit of intensity with each loop now. Here's the part that makes glories especially rare. The droplets have to be almost perfectly uniform in size. If the cloud contains droplets of many different sizes, the interference patterns get blurred, and the glory fades away. That's why you usually only see them in certain types of mist or clouds, like those found on mountaintops or in altocumulus layers. The droplets there are often similar in size, creating the perfect canvas for this light show. What's even more fascinating is that the glory is deeply personal. The rings always center perfectly around the antisolar point, the spot exactly opposite the sun in the sky, which is also where the shadow of your head appears. So when you see a glory, you're not just seeing a random pattern. You're seeing a phenomenon aligned precisely with your own perspective. If you move, it moves with you. If someone stands beside you, they'll see the rings around their own shadow, not yours. It's a private audience with light itself. Scientists struggled for years to replicate glories in the lab. It wasn't until the mid-20th century that a full mathematical model explained the complex wave interactions. Today, we know that glories aren't just beautiful quirks. They're used in atmospheric science to determine the size of cloud droplets from aircraft or satellites. By analyzing the rings, researchers can learn about the composition of clouds and even the atmospheres of other planets. Venus, for example, has a sulfuric acid cloud layer that can produce glories detectable by space probes. But you don't need to be a scientist to feel the wonder of a glory. Standing on that ridge, watching colored light encircle your shadow, you become part of the phenomenon. You are both observer and catalyst. The light needs your position, your shadow, to complete the picture. It's a reminder that nature's most stunning displays often arise from the simplest ingredients: light, water, and a single point of view. Have you ever seen a glory or another rare optical phenomenon in nature? Share your experience in the comments. We might feature your story in our next video. And don't forget to subscribe to Nature Unlocked for more mysteries of the natural world explained.